Good day, everyone. I am Noel Manigang Jr. of ECE 5C of Technological University of the Philippines, Visayas, and I am here today to teach you about matrices. So, at the end of this video, we will going to understand what is matrix, know the order of matrix, adding, subtracting, multiplying matrices. First, let us know what is matrix or matrices. So, matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. First, let us talk about the order of matrix. So, let us consider matrix A, which has a number of 2, 6, 7, 3, -4, and 5. Now, what is the order of this matrix? Now, this matrix has 2 rows and 3 columns. So, what is the order of this matrix? Now, this matrix has 2 rows and it has 3 columns. And now, the rows are horizontal and the columns are vertical. Now, this is a 2 by 3 matrix. Now, let us identify a specific element in a matrix. For example, what is the element of A, 2, 3? So the first number is the row and the second number is the column. So we can see that there is a 2 and we can find out that it is in the second row. And the second number is 3, which we can identify that it is in a column 3. So the number is number 5. So the element in this matrix A23 is equals to 5. Now let us have our second example. So for example, we have B, which is equals to 4, 5, -3, 3, 6, 8, 7, -4, 1, and -2, 9, -7. So as you can see, we have 3 rows and 4 columns. So this matrix is a 3 by 4 matrix. Now, let us identify these elements. So we have B11, B23, B14, and B34. So that you can identify directly what is the answer for these elements. So let us go ahead and find what is B11. So B11 has 1 row and 1 column. So it is in number 4. So the answer is number 4. So the second is B23, which is second row, and the third column. So it falls under number -4. So the answer is -4. And in the third one, we have B14, which is 1 is the first row and 4 is the fourth column. So the answer is -2. And on the fourth one, we have B34, which falls under third row and fourth column, which is number 7. Now let us learn our third topic, which is adding, subtracting, and multiplying matrices. So provided that they have the same size, two matrices can be added or subtracted element by element. And in the multiplication, the rule, however, is that two matrices can be multiplied only when the number of columns in the first equals the number of rows in the second. So let us now go ahead and have an example for adding two matrices. So for example, we have A, which is equals to 3, 8, -4, and 5. And we have B, which is equals to 9, 2, -5, and -6. So as you can see in this example, we have a 2 by 2 matrices. So the rule in adding and subtracting matrices is satisfied. And now we can go ahead and add this example. So let us add A plus B. So all we have to do is to add the first column and the first row of both given A and B. So in this first column and row, we have number 3, which is to be added on the second given, which is number 9. And on the first row, second column, we have -4, which is to be added to -5. And we have number 8, which is to be added to number 2. And we have number 5, which is to be added also to -6. So we will get an answer of 12, -9, 10, and -1. So after adding, let us go ahead and do some subtracting of matrices. So for example, we have a given of C, which is equals to 7, 8, -2, and 3. And we have D, which is equals to 6, 5, -1, and 3. So as you can see, we have a 2 by 2 matrix. So let us now go ahead and subtract C to D. So let us first subtract 7 minus 6 and -2 from -1 and 8 minus 5 and 3 minus 3. So 7 minus 6 is 1 and -2 minus -1 is -1, And 8 minus 5 is 3, and 3 minus 3 is 0. So that is our answer. Now let us go ahead and multiply matrices. So for example, we have a given of A, which is equals to 2, 5, and 6, and B, which is equal to 4, 3, and negative 5. So the product of A, B, and BA is what we are going to solve. So basically in math, we all know that, for example, 3 times 5 is equals to 15, and 5 times 3 is also equals to 15. Now, in matrices, the order really matters. So, AB is not equal to BA. Now, as you can see, matrix A has 1 row and 3 columns. So, it is a 1 by 3 matrix. And matrix B has 3 rows and 1 column. So you can see that these two are the same, which is we have satisfied the rule in multiplying two matrices. So the output of this product, you can identify the order of element by knowing these two. So it is possible that the product of this A and B. Now let us go ahead and multiply A with B. So AB is equals to 2 times 4 plus 5 times 3 plus 6 times negative 5. So 2 times 4 we have 8, and 5 times 3 we have 15, and 6 times negative 5 we have negative 30. So 8 plus 15 minus 30 is equals to negative 7. So you can see we have a 1 by 1 order of matrix. Now let us go ahead to our final example. So example, we have A, which is equals to 1, 3, 4, 5, negative 2, and negative 6, which is to be multiplied to B, which is equals to 5, 3, negative 2, 2, 6, 9, 8, 4, 7, and negative 1, 5, negative 3. So you can see we have a 2 by 3 matrix for letter A, and in letter B we have a 3 by 4 matrix. So let us find out if these two matrices are possible to be multiplied with each other. So we have 2 by 3, which is to be multiplied to 3 by 4. So AB is, there are the same number, so it is possible that we can multiply A with B, and the output will be a 2 by 4 matrix. So let us now find out if B and A are possible to be multiplied with each other. So B times A is 3 by 4 and 2 by 3. So As you can see, these two numbers are not equal, so it is not possible for these two matrix to be multiplied. So this example is, we can say that it does not exist. So we cannot multiply B with A. Now let us go ahead and multiply these two matrices. So what we are going to do is to multiply each row to the columns of matrix B. So for example, we are going to multiply this row with this column. So we have 1 times 5, which is equals to 5, and 4, which is to be multiplied to number 3, which is 12, and negative 2, which is to be multiplied to negative 2, which is 4. And now secondly, we have to multiply this second row to the same column. So we have 3 times 5, which is 15, plus 5 times 3, which is also 15, and negative 6 times negative 2, which is 12. And all we have to do is to multiply this row again to find out the other missing for the rows in this matrix B. So we can go ahead and do that. So we have 1 times 2, which is 2, plus 4 times 6, which is 24, and negative 2 times 9, which is negative 18. So second row, second column again, we have 3 times 2, which is 6, plus 5 times 6, which is 30, and negative 6 times 9, which is negative 54. Then the third column, we have 1 times 8, 1 times 8, which is equals to 8, and 4 times 4, which is 16, and negative 2 times 7, which is negative 14. So second row, third column again, we have 3 times 8, which is equals to 24, plus 5 times 4, which is equals to 20, and negative 6 times 7, which is negative 42. Now let us proceed to the last column. So 1 times negative 1 is equals to negative 1. 4 times 5 is equals to 20, plus negative 2 times negative 3, which is equals to 6. And now let's go ahead to our last one, which is 3 times negative 1, which is negative 3, plus 5 times 5, 25, plus negative 6 plus times negative 3 is equals to 18. So we will get an answer of, we can understand that 5 plus 12 plus 4 is equals to 21, and 15 plus 15 plus 12 is equals to 42. Here we can get an answer of 8. Here we can get an answer of negative 18. And in here we have 10. Here we have 2. And in this one we have 25. And finally we have 40. So that is the final answer in finding A times B. Applications of matrices both in mathematics and other sciences. Some of them merely take advantage of the compact representation of a set of numbers in a matrix. Example, in games and economic, the payoff matrix encodes the payoff for two players depending on which out of a given set of alternatives the players choose. Text mining and automated, the Series compilation makes use of document term matrices such as to track frequencies of certain word in several documents and etc. So that's it, guys. That's the end of our lesson for today. Thank you for watching and have a good day.